I'm Dennis Wade, and we're here at Storage Visions 2013 in Las Vegas, which is one of the larger conferences focused on storage technology, where we need to go in the future, and what's going on today in the industry. And with me now I have Michael Willett. Michael's with Samsung. He's also been on the board and an active member in the Trusted Computing Group, and that group represents the industry in terms of security algorithms, future directions of some of the software, and where we want to go. And Michael's going to talk to us today about both of his jobs, one being the Trusted Computing Group, second being Samsung and some of their products and where they're going. With that, Michael?
Well, Dennis, thank you. It's exciting to be here at Storage Visions. I've been here several years now, and it's always a leading-edge conference. You learn everything you need to know and more about flash and solid-state drive and so on. So it's a very interesting conference. I'm here, as Dennis mentioned, representing first the Trusted Computing Group. It's an industry consortium, about 140 or 50 members. What we do, we create specs. So the industry gets together. For example, I'm on the storage work group. We have a subgroup that meets. All the drive industry representatives are on that committee. For several years, they worked together to create a specification for trusted storage. We published that specification, and now the various all the major drive companies, both solid state and the hard drive companies, also both laptop and data center drive people, have all built to that specification. And the particulars of that specification are what's called self-encrypting drive. So as we all know, and we should know in security, that data, sensitive data especially, needs protection. And the best protection for stored data is encryption. In fact, there's a little mantra in the industry security world that says that all stored data should be encrypted. Now, that's a good mantra, but we know that's not always the case. A lot of data that's in storage is neglected in one sense, and it can fall into the wrong hands. So the idea is that I want to encrypt all stored data, and the easiest way to do that is with technology built directly in the storage system itself. I mean, the traditional techniques are to rely on software running over some distance away on an operating system, on a platform, but that's a level of indirection that creates vulnerability. That is, if I'm encrypting over here, and I'm storing over here, and I'm decrypting over there, I'm storing the keys over there, there's an opportunity for some vulnerability. Whereas if I encrypt directly in the drive itself, in drive hardware, I really have maximized the security of the storage.
So if I listen to you, the goal in that is that at some point in time in the future, hopefully, every device will be encrypted. The user will not know that it's encrypted or need to know that it's encrypted, but the data will be 100% protected, and the lost data, and in fact, you might go into a little bit what happens with lost data, but the whole security problem kind of dials down to about 10% of what it is today, or possibly even goes away.
Dennis, exactly. All data should be encrypted, as we've said. Best place to do that encryption is in the hardware itself, in the drive electronics itself, with no performance impact on the performance. The prime directive, if you will, of storage is to store, but yet this encryption, as we've built it in hardware, has no performance impact on the reading and writing in the drive. So, and Dennis mentioned the vulnerability and the loss. And there are two ways that this technology comes into play in a real way. One is protect you against loss or theft. You mentioned that. If I lose my laptop or I misplace it, that's an exception condition. We don't always want that to happen. Of course, the FBI has shown in their statistics that it's happening all the time. I mean, there's probably in every airport in America, there's a laptop either being lost or stolen every few seconds, in fact. But those are exception conditions. But also there are other times, regular business processes, in which I lose control of my data. If I send my drive out for warranty work or repair work, or I end of life the drive, or somebody wants to sell my drive on eBay, I'm losing control of data that's potentially still on that drive. So for those normal business processes, I still want the protection of encryption. Now, the most motivating factor in all this, by the way, is regulation. In the 47 or 8 states in the United States, the federal government, and now the European Commission, there are what are called breach notification laws. And what's happened there is the governments of the world have noticed that we're losing an awful lot of sensitive information on the people of those countries. And so that's a political issue, if nothing else. and that sensitive data is being lost. It's medical information, personal information, and so on.
Strategic information.
Strategic information, exactly. What's being carried. Exactly. So all kinds, and if you look at the databases that maintain these loss or theft statistics, it's frightening what sort of things are being lost or stolen every day. So the breach notification laws say that if you lose data, first you should protect the data. But if you lose data that's sensitive, that you have to notify your public, the affected public. And this can be expensive, time-consuming. It can affect embarrassing. It can actually cause a company to fold. We've had companies fold because they've lost the customers have lost trust in that company. And also it brings out an army of lawyers. I myself personally was on 2 different breach notifications within 3 months of each other for my name on various databases that were lost. But yet if you can prove, there's a little clause in the breach notification laws that says what's called encryption safe harbor. If you can prove that the data was encrypted through logging and so on that some of the management functions provide, if you can prove the data was encrypted, you don't have to breach notify. And that can save you a world of hurt to do that. So this issue is a compliance issue, encrypting stored data, that goes not just to the IT guy, but it goes all the way to the headquarters. It goes all the way to the CEO. Because the CEO and those folks, that level, the C level, is very concerned about compliance when it comes to compliance. So that's that's the big motivator for this technology and for all the drive companies to get into this business of self-encrypting drives.
Also, could you talk a little bit about the encryption being personalized to the individual from the standpoint of if you do have a lost product, a laptop, drive, whatever, and you find it later on, only that one individual that originally had that data, controlled that data, can now access that data?
Dennis, that's a good point. I'm glad you're asking me to delve into the technology because that's what I love to talk about. But just to keep lightly, the encryption key itself that encrypts everything is never externalized. It never leaves the drive. In fact, the key is generated by the drive itself with random number function inside the drive in the manufacturing process. So when the drive comes to me, it's encrypting. It's already encrypting. It was born encrypting. It continues encrypting. I can't shut off the encryption. Your users can't shut off the encryption is more important fact. And so it encrypts throughout the life of that drive. But yet for my personal control, when I take control of the drive, I personalize it with what's called an authentication key. So I have a long key that I can use either through dongle or biometrics or automation processes, whatever is user-friendly for me.
Another level of protection above the encryption.
Exactly.
In addition to the encryption, which is an ongoing algorithm that changes every second, every day, you've got your own privacy code that you know about.
Exactly. It's sort of a separation of control. Yes. The drive has a certain level of control in using the encryption key.
It's another dimension on the security.
And above that, it's a security level where I control the authentication, either through automated process or through my manual entry if you want it at a workstation. And the important thing about this is that whole authentication process is not driven by the operating system, because then I'd fall back into another weakness. Right. It's driven by the drive electronics. When I turn on my laptop in the morning with a self-encrypting drive, before the OS is loaded, the drive sends me a request for my authentication key. So the drive microcode is talking to me and says, what's the authentication key, which I had previously personalized. It checks the authentication key I enter, and if they match, then it unlocks the drive and then falls into normal function. So as you asked earlier, if my drive is lost or stolen, that drive is locked. All the data is encrypted, and the drive is locked and can't be read by anyone who doesn't have the authentication key.
So if you take a look at, say, some of the military uses and classified data and things like that, your system replicates a little bit of what they try to do in those systems to make them 100% foolproof in terms of security.
Exactly. One of those conditions being sort of the separation of authority.
Yes.
You know, we've got a strong separation of authority where the drive has a certain level of control over the encryption, and I own the other half of that encryption. And you mentioned the military. One of the functions that's available with self-encrypting drives that the military is very interested in and has just been standardized, by the way, by the National Institutes of Standards and Technology in their new sanitization document, and you lose your inventory, plus it's a very expensive and, by the way, error-prone process. self-encrypting drives, I have a very simple sanitization technique. All I do is ask the drive through executive command to delete and replace the encryption key. The only copy of that key is on the drive because it's never externalized. And when I delete that copy, the data is sanitized. That is, the data is no longer readable because it's strongly encrypted. It's in encrypted form. No key is available to the encryption function now, so that you can't read the data. Yet a new key is generated in the drive that allows you to continue to use the drive as a new drive. I can reformat, and it's as if the drive came to me from the factory, and I don't lose. I'm not only sanitized in milliseconds, but now I still have the drive in my inventory.
That's fantastic. I would think that would save a lot of drives that are put on the scrap heap that don't have to be put on the scrap heap because they can be reused. And it's, you don't have to worry about taking a hammer to the disks and the magnetics and all that sort of thing. It's automatically done, and there's no chance of anybody else even picking up bits and pieces of that because of the encryption.
Exactly.
Okay.
In fact, good point you make. One of our, we have several of the top-of-the-line data recovery companies here, like Kroll OnTrack, for example. They can take those little pieces of disk material, by the way, and recover data off. You don't have to have the platter. You just have little pieces of that material can recover data. So those are some not foolproof methods that are used traditionally. But with crypto erase, it is very robust and very instantaneous. And so NIST was very interested in that and has standardized on that as a new technique for sanitization.
While we have you here, do you want to say a few words about Samsung and what Samsung might be doing in some of these areas?
Okay. Well, Samsung, putting my other hat on for a second, Samsung has been a major contributor to the storage work group within the Trusted Computing Group. And in fact, Samsung was on the board of the Trusted Computing Group for a while. What we did was to develop the first solid-state self-encrypting drive. So the company Seagate and other companies that led the early development had developed rotating media drives, hard drives, that implemented self-encryption. But as I say, Samsung was the first one to develop the solid-state self-encrypting drive, which fits very nicely into the theme, of course, of this conference, of the Storage Visions Conference.
Both of those devices, so your whole system is really encrypted.
Exactly.
The same methodology.
Exactly. And the nice thing about the standardization, by the way, you mentioned that, is there's a common, the big thing about, I mean, everybody can encrypt, and everybody can build encryption chips, because that's all been standardized through the advanced encryption standard. So everybody uses the same algorithm these days. It's not, I wouldn't understand the reason for making up a new algorithm, because these are time-tested, very robust algorithms that are national and international in scope. But yet, what the TCG workgroup has done in the specification is to find a common interface to the drive, so that there's a common management interface for managing the self-encrypting drive. That's why we have software vendors now that provide enterprise management of encryption that are very easily can extend their management support to various companies. So you'll find software vendors, in fact, at this show, that manage 4 or 5 different brands of self-encrypting drives, all from basically the same interface, not only locally but also from a central point of view, where you want to manage large numbers of self-encrypting drives, because they have that common interface on the drive to interact with the drive.
Which means they don't have to concern themselves with the encryption. It's pretty much automatic as long as the standards.
Exactly. They again, separation. The drive owns the encryption. The drive owns the hardware and the encrypting key and so on. Yet I can manage such things as the authentication key, and I can back up and archive the authentication key and that sort of thing. So I provide a sort of a graphical interface through the software vendors to the management function itself, and then centralized management. We're having companies now that are buying. They've tested the self-encrypting drive. They're starting to deploy and roll out, and they're buying hundreds, and now they're buying thousands and tens of thousands of self-encrypting drive in the normal replacement process. I mean, the bottom line here is you do have to buy new hardware. The drives are new. But yet what our big customers are finding is that they can just roll that in. They're going to replace the laptops on a 3-year basis, other data center equipment, and then just roll it in as you normally do, and you buy this latest technology, self-encryption.
Michael, thank you very much. I think we've learned a lot today, and we appreciate your participation in the conference. It's been a nice conference. Thank you.